Hello, everybody. My name is Daniel. I work for a company called Agfo, and we are here today to talk about efficient developers. So the first thing that I want to do is define what we mean by efficient. To be efficient means achieving maximum productivity without wasting resources. And in our case, as developers, that resource is usually time, which means to be efficient is to do things fast. But this definition is missing one key element for us that we can see in this quote by Peter Drucker. To be efficient is to do the things right, while to be effective is to do the right things. So to be efficient is not that we have to be very, very fast. It's the things that we do, we have to do them in a proper way so the decisions that we take today don't slow us down in the future. Now that we have this quote here, you may be wondering, well, what is more important, to be efficient or to be effective? Obviously, it doesn't make any sense to go really, really fast if you end up in the wrong place. But equally, if we know where we want to go, but we never achieve that place, it doesn't make sense either. In fact, there is some synergy between the two. If you are efficient, it means that you spend less time, takes you less time to do things, which means that you have more time in your hands to stop, look around, and make sure that you are going in the right direction. So to be efficient allows you to be more effective. Now, in this talk, we are just going to focus on what it takes, what it makes us efficient. And we're going to start talking about focus. There are plenty of studies that try to quantify what is the cost of an interruption for us developers. And it seems that the cost is around 10 or 15 minutes. So every time that somebody comes and interrupts you, it takes us between 10 and 15 minutes to reload the context of the task that we were doing to be able to be productive. So it's paramount to be efficient, to minimize the number of interruptions that we get. So we have long periods of time where we can focus on the task at hand. There are basically two types of interruptions, the ones that you control and the ones that other people control. Of the ones that you control, these ones, email notifications, are probably the worst offenders. If you think that that little pop-up does nothing for your concentration, the truth is that for your brain, it looks more something like this. You cannot just stop looking at it. Millions of years of evolution have made our brain really sensible to any unexpected movement, mostly because the fear of being eaten. So when that little pop-up shows up on your screen, you have to focus on it. You don't have an option. So efficient developers, the first thing that they do, they disable all notifications. Not just email notifications, but absolutely all notifications. In fact, you don't even want to see that little number with the number of unread notifications on your screen. Because as soon as that little number changes, your brain is going to pick up the change. And you're going to start thinking about, well, who sent me an email, or what do I need to read? So you should always, you can always deal with emails whenever you want, whenever you have the time. Nobody should expect that you reply immediately to their emails. There are other means of communication that are more appropriate if something is really, really urgent. Emails are asynchronous, and it's more efficient to deal with them in batches. The only notification that you want to see is the one that tells you that you broke the build. Yeah. And please never be one of these guys that they type an email and they run to tell you just to make sure that you received that email. This is really, really annoying. And this brings us to the other types of interruptions, the ones that you don't control. What can you do when somebody comes to your desk and interrupts your flow? I know of three possible options. The first one is to wear some headphones, really, really big. So when somebody comes, you pretend that you didn't see him. And you hope that he will just walk away. The second option is that you have a very good team lead. Somebody like this guy. Somebody that is able to tackle any interruption before it reaches the team. The third option is to do pair programming. If you are doing pair programming, when somebody comes to interrupt you, what should happen is that one of the two developers in the pair should stand up, walk away a couple of meters, and deal with the interruption. And when he's done, he goes back to the other pair. And that other guy that was able to keep focus, it works like a really fast cache to get him into a productive state a lot faster. The additional benefit of pair programming is that because you have another developer looking at what you're doing all the time, you are not going to check the news or your phone or your email as often. So that peer pressure is just going to cause you to be more efficient. I don't think I need to explain this, right? We all know this. And I don't like to sound like your mom when she tells you to eat your greens. So let's move to the next one. Efficient developers just do one thing at a time. And the reason is exactly the same why we hate interruptions. Yeah? Because of the context switches. Here we see that doing the blue task after finishing the green task, it just takes less time. In fact, it's not just that it takes less time. When you try to do multiple things at the same time, the quality of your work usually suffers. We all know that the definition of multitasking is just screwing several things at the same time. So you should always focus on one thing, if you finish, and then you move to the next task. You, me, we are all going to spend thousands upon thousands of hours in front of your IDE. It's one of our main tools. So you really need to know it inside out. Because any efficiency that you gain using your IDE is going to be multiplied by those thousands of hours that you are going to spend in front of it. You just basically need to know two things: its functionality and its shortcuts. Now, just because you are sitting already in front of it for 6 hours a day, it doesn't mean that you are going to master it. To master your IDE, you have to make a conscious and deliberate effort to learn it, to find what functionality you don't know about it. You can read the release notes, you can follow blogs or YouTube channels of people using it, or you can just do pair programming. When you do pair programming, each of your partners is going to show you how they use the IDE, and it's going to show you functionality that you didn't know about, or it's going to show you more efficient ways of doing some task. Also, you can teach him your tips and tricks, so you make the whole team more efficient. I'm always surprised about the amount of manual work that we developers can put up with. And I found it very paradoxical, given that we are paid to automate other people's job. Manual work is not just slower to do, but it's dull, boring, and it's error-prone. So I always wonder, well, why we keep doing it? I think one of the main reasons is that we sometimes forgot that we are developers. And as developers, we have this very rare and powerful skill that allow us to create an army of minions that will do as we say. They will not complain it, they never get tired, and they do it really, really fast. And I think we don't use this skill often enough. Sometimes it's maybe because we just end up with this kind of minions, but that's a different talk. Just to make sure that these things, I'm going to repeat it again. You are developers. You don't do things that your computer can do for you. So efficient developers, before starting any task, they always think, well, can I write a program to do the task, or at least to help me to do the task? And I'm not just talking about automating some work that can take you hours. I'm also talking about automating tasks that can take you 5 seconds, but you do several times a day. And I'm also talking about writing programs for one-off tasks that you're never going to do again. First, because maybe it's more efficient, you can do it faster. But second, because I hope that writing programs is fun. At least it's fun for me. More fun, at least, than doing things manually. To write simple programs, there is nothing like old good bad shell. I have been a developer for 18 years, and during those 18 years, I have changed operating systems, I have changed programming languages, I have changed IDEs, I have changed my mind about all kinds of ideas and practices. The only thing that has been constant during those 18 years has been Bash. So I want to show a little demo about what Bash can do for you. Is that big enough? Big enough at the end? Cool. So let's say that your business manager tells you that some other team has created a program, and that program is collecting news. And he wants to know how many news per country we have. So you jump into the box, and the first thing that you're going to do is write a program. This is a program that is going to tell you how many news we have. This is a program, right? Around 4,000. So now, let's see what we have in one of those news. So it seems that it's a paste of JSON, right? But it's kind of hard to read, so we format it. So we see here some news with an ID, some social stats, the site that it comes from, and we have here the country. Yeah? So what we are going to do is write a little program to extract that country. So country, quote, quote, single quote, come on, single quote. OK, let's see if that works. Yeah, so we see, where's my mouse? Here, the country. So now let's try to extract it. We start doing grep -o, we get something, and now we want to get the whole line. So you don't get too lost. Here it is, our result, country, and then we have the US. So what we are going to do is now split the line with a delimiter of quote, and we want the field, I think it's the third or the fourth. It's the fourth field. Cool, so now what we have, it's a program to extract the news, the country for a news. So we just want to do the same for all the news, and now we just need to sort it and count it. There it is, because we want to sort it again, so we see it in order. So we get that for this country, there are around 3,000 news. But now that we have this program, let's say that instead of the country, we're interested on the site. Yeah, we see their number of news per site. But now your business manager comes and says, like, well, I want to know what are the top 3 websites for each country. So we're just going to modify this program a little bit. We grab country. Let's try, for example, IL. And if I didn't get that wrong, those are all the countries, so we just want to sort them and take the top 3. That's it, and now we are going to format it. So it all shows in one line. So now we have a program that for one given country, it tells us the top 3. So we just need to do a for loop, right? We just need to find all the countries that we can get basically from our previous program, and we just need to write a for loop. For E in this, 2, we echo the name of the country, use -n, and we finish the for loop, and go back. And instead of IL is the country that we want to know about. And because this is bash, I need to quote, 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 unquote, quote. And I got something wrong. Did I miss anything? There's a new error. What did I get wrong? Cat, unique, Site, what? It doesn't matter. So I'm going to then move to the next thing, that is, whenever you are writing a program, you should always time limit the amount of time that you are expected to use on it. This is a good example, right? Because if I keep going, I will spend the next 25 minutes just trying to get it working. So whenever you are trying to write a program or automate a task, the first thing that you should do is time limit it. And if after that time limit you are not able to finish it, just move and do things manually, right? Now, even if you think that that's a waste of time, right? I tried for 5 minutes to get this thing working, and it didn't get it. Well, the truth is that you have learned a little bit. That's not wasted time. That's invested time on you learning, on getting better. OK? So whatever. Yeah, there is a nice table from XKCD that tells you how much time you can spend to automate some tasks. So have a look at that. And if we are talking about writing programs, what you should always do is you will want to avoid graphical user interfaces. Why? Because you cannot put a UI inside a for loop. UIs don't compose. They just live in their little world. Now, I'm not saying that you should never use them, because they are extremely useful when you are getting started, when you are learning something new. But once you are past that phase of beginner, you will actually want to do more complex stuff. And UIs just constrain what you can do. And if we're talking about avoiding UIs, the first UI that you want to avoid is your own application's UI. Right? There is nothing less efficient than starting your application, clicking things around, and filling up forms to know if your feature, the new feature, is working, or if you broke anything. Apart of making this thing more efficient, automated tests also give us the confidence to refactor and change code, because it's going to catch bugs. And bugs are the worst time waste of all. First, you need to write the bug, then somebody has to review the bug, then you need to put the bug into production, and then by the time some user notices the bug, you have gone through this massive context switch because you probably wrote the bug several weeks ago. And so, even if you wrote the code that has the bug, that code is already alien for you, and you have to dig into it, and then you need to fix it, you need to code review it, you need to explain it to your boss, you need to fill some Jira issues, and then you need to go again through all the release process. So bugs are just a big waste of time. But worse than a bug, it's having the same bug twice, right? So whenever you go and fix a bug, the first thing that you should do is write a test to prove that you are able to reproduce the bug. You see it fail, and then you fix it. And the last thing that you want to avoid to do manually is setting up the development environment, right? This is not going to make you just more efficient, but the whole team more efficient. This is how the instructions for any project that I join look like from my point of view. And the only thing clear on them, about them, is they're not going to work. Maybe they are missing some step, or they're not precise enough, or maybe I will make some silly mistake when I try to follow them. And the result is always the same: 2, 3, 4 days of wasted time. What you want to achieve is instructions as close as possible to this, just one command. And that one command should bring all the tools and configure them to be able to build, run, and test your application. If you need a database, it should install the database and configure it and seed it with some data. If you need any build tool, Maven, NPM, whatever, it should download the correct version of Maven and install it and configure any SDK that you need. As you can see, my tool of choice right now to do this, it's Docker Compose, which is part of the Docker suite. If you are not familiar with it, this is an example. And here we are saying that our development environment, it needs 3 containers: PostgreSDB, Redis DB, and our own application. This has multiple benefits, right? First thing, it takes just minutes for somebody new to get started. But also, if something stops working on your development environment, you can just easily just wipe the whole thing and start again. If there is change on the development environment, it's shared immediately with the whole team. And the instructions never get out of date. Also, because Docker is running things in isolated environments, it means that if 2 projects that you're working on, they use completely different versions of a database or a SDK, well, they're going to be completely isolated, so it doesn't bother one another. And also, because it's so easy to make changes, it encourages you to experiment. If you want to try a new JDK or SDK or a new version of the database, just make the changes, start it, and if you don't like it, you just completely wipe the whole environment. And the last section that we are going to talk about, feedback. It doesn't matter what you are working on, you should always try to find the shortest and tightest feedback loop possible. Feedback is what it tells us if we are going in the right direction. Feedback makes us, at the same time, more efficient and more effective. You want feedback often and early to make sure that you don't wander on the wrong path for too long, with the consequent waste of time and energy. If we talk about the benefits of automated tests, we save time, it catches bugs, it allows us to refactor. When is the best moment to write tests? Well, my opinion is before you start doing any coding. If you're not familiar with the TDD workflow, it's basically this. I'm going to go really fast through it. You first write one test and only one test. You run it. You see it fail. You see it red. And then you just write enough code to make that test pass. And then you refactor. You clean up your code, running the test just to make sure that you didn't break anything. There are at least 4 reasons why you want to use this workflow. The first one is the fast feedback that it gives you as you are building the new feature to know that your code is doing what you expect it to do. The second reason is that if you truly believe that automated test saves you time, you want that benefit as soon as possible as you are developing the new feature. The third reason is organizational. I have here used too many times the phrase, I don't have time to write tests, or I'm not given the time to write tests. And for me, it just actually means that, well, I always write my code, I finish my feature, and once I have finished my feature is when I do write my test. And if there is any time pressure, well, I'm not going to, I don't get time to write those tests. And because you don't write tests, it means that you don't refactor your code. Because to refactor code, you need a very good automated test suite. And because you don't refactor code, it means that your code starts to accumulate garbage. And because your code starts to accumulate garbage, it takes you more time to actually build new features. And because it takes you more time to build features, you get more time pressure. And you get more time pressure, so you have less time to write tests. Closing a vicious cycle that always ends up with the same, with us developers crying for a rewrite. And the fourth reason why you want to write your tests first, it's one of a mechanical reason. Because seeing a test fail is the test that the test tests what it's supposed to test. Or in simple words, how do you know that your test doesn't have any bug? If you write a test and you see it red, there is a strong indication that is some piece of production code, some logic that is not there. If you write a test and you never see it red, well, you don't know if it is because you already implemented a feature or because you forget an assertion in your test, or the setup code is not correct. Now, when you present this idea to a lot of people, they always come up with this phrase, I cannot write a test first because I don't know what I'm going to build. And this can mean different things. It can mean that you don't understand what business is asking you to do, right? And in this case, it's true, you cannot write any test, but you cannot write any production code either. What you have to do is go back to business and ask for clarification. What do you want to do? The other case is that you actually understand business, and you actually understand the logic that you need to build, but you don't know if you're going to write 1 class or 10 classes, or if you are going to put an if statement or a switch or a factory. You don't know what you're going to write, but you understand the logic, and you now understand the mechanics of the side effects. So you know which database you are going to use. You have used it 10,000 times already. You know the table. You know everything. In all these cases, you can actually run a test first. But it's true that sometimes we actually don't know how to do the side effects that we are asked for. With, for example, maybe the logic for your new for a new functionality, it needs to call some RESTful endpoint to get some Forex exchange. And you have never used it, and you don't know the endpoint, and you don't know what you need to give to it, and you don't know what it's going to give you back. Or maybe you need to consume some messages from a message queue, and you have never done that, so you don't know which libraries to use, you don't know how they work. In all those cases, you don't really know what you are going to do. There is always this phase of exploration that we have in our job that we use to fill up those gaps to convert unknown side effects into known side effects. And that's something that TDD doesn't help you with. What you want to do is first read the documentation to see if you are able to fill those gaps. And the second thing, you want to write a lot of little programs to test, to play around with that technology. For this, the best tool that I know, it's a REPL. REPL stands for Read, Eval, Print Loop, and it's just basically a fancy way of saying that you have like a command line interface inside your application. Instead of trying to explain it, let's see it in action, if it works this time. So I have already started an application with a REPL inside, and what I'm going to do is from my IDE, I'm going to connect to that REPL. So let's say that you didn't know how the plus function works. So I write a piece of code in my IDE, and I'm not using a shortcut to send that piece of code to the application. And the application tells me that 2 plus 3 is 5. Yeah? So I write the code on the top screen, and I get the results on the bottom screen. So as I was saying, this allows you to experiment with the library. So maybe what happens if I pass 3 parameters? Seems to work. What happens if I pass a very big number? I get an exception. What happens if I just pass 1 parameter? It works. No parameters, it works. So this is just understanding how the library works. And this could be an HTTP library, messaging library, some concurrency library. We are just writing little programs and executing them to see what's the result. Let's do something slightly more fancy. Let's say that your business manager, it tells you that you have to build a new feature, and you need some for exchange for that feature. And one of your mates told you that there is a RESTful endpoint to do that, and it gives you the URL. So we wrote an HTTP, we make an HTTP request, and we see that we are getting some exception. Let's try to format that. Let's catch the exception. Try catch exception. OK, let's run it again. So it tells us it's a 400, which means it's our fault, and we see here some body. So what we are going to do is let's get the body. OK, that seems some piece of JSON, so let's parse the JSON. There it is. So it seems that we're missing some data. Let's pass some query parameters. Yeah, we get the exchange rates. What happens if I pass an older? What happens if I pass something in the future? Oh, it still returns data. That's a little bit worrying. What happens if I pass a string? I get that error. So what we are doing is exploring how the real world works and how we are doing it. We write a little program, we run it, we see the result. So it's a very, very fast feedback cycle. Now you may be wondering, well, why don't you use something like Postman to do this, right? It's just HTTP RESTful, must be Postman. Well, there are some benefits of doing it like this way. The first thing is you have a full language. This is the production language, the one that I use in production, which means that I can do for loops and if statements. If I want to mix this data with something from the database, well, I know how to make database calls from the JVM. And also, if I now go and I grab this exploratory code inside a function, and I don't get it wrong, this that you see here, this is production code. As you see it there, it's going to go to production. I'm making the changes in the project. This is not a different tool that then I need to get what I got from the tool and translate it to Java or .NET or whatever you are using. This is production code. It's ready to go. Also, because the REPL is running inside your running application, you can actually go and poke at the state. You can look at the state of your running application. And what we are doing here, if you notice, we are modifying a running application. And we are doing all of this without having to compile or restart anything. That's a very, very quick feedback loop. And I don't know if I mentioned it, but we are connecting to this REPL through a socket. And because we are connecting through a socket, it means that we don't really need to be running this process in my local box. It can be running in test or production. So you could be specing, modifying, adding log statements into production code without stopping the application. This is extremely powerful. And with great power comes great responsibility. So use it with care. The last thing that we are going to talk about is code reviews. Code reviews tell us if the design of the code that we are doing, if it fits the application. It allows one of your teammates to tell you if you have any bugs. And it also, we can use it to share knowledge, right? It's a way of sharing knowledge. So efficient developers want their code to be code review. Now, there is something very true behind code reviews. When we are presented with these huge, massive changes, I don't know what's your reaction, but my reaction is something like, oh my God. Yeah, when we get those, but when we get small changes, we are able to give useful feedback to the author of the change, right? Because we are able to understand the change. Also, even if you are a very disciplined developer and you go through that really painful review process, in my experience, what does it happen when you go and tell the author, like, well, you know, I think your design is your shit. No, not your shit, sorry. We could improve your design. Or we could use a different library that will save us some time or some resources or whatever. What usually happens is the author says, like, yeah, I think you are right. But you know, I have already spent like several days or weeks working on this. And the end of the sprint is tomorrow. So even if I think you are right, I don't think I'm going to have time to do your change, what you are suggesting, because it's going to take me several more days to do it. Also, you know, it's already working. So let's do something different. Let's just commit the change as it is, and we are going to ask the product owner to create a refactoring story. I'm sure he will be delighted to put it on top of the priority queue. And we all know that those things never happen. So you end up again with worse code that leads to slower implemented feature with blah, 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 blah. So efficient developers, they don't want just code reviews. They want small and early code reviews. So what they actually want is continuous code reviews. This practice consists on getting one of your teammates to sit just beside you. And as you are implementing the feature, this developer sitting beside you is going to suggest improvements on your code. It's going to be catching bugs that you are doing. And for the reviewer, the changes are really, really small. Yeah? As you type them, he sees those changes. And for you as the author, you can get feedback even before you start writing any code. Additionally, if for whatever reason you are not able to finish the feature, this other developer is able to pick up that feature without any effort, because he has been behind each of your decisions. So you avoid those knowledge silos within the team. Also, this other developer can work as your personal Stack Overflow, because maybe he has already found that similar issue and he already knows how to fix it. And sometimes you don't even need to ask the question, because he sees what you are doing. Some people call also this pair programming. So that's all that I have. Very briefly, focus, master your IDE, your tools, avoid manual work, and find yourself the fastest feedback loop possible. And last words, you should always find time to stop, reflect on how you are working, and never, ever stop learning. Thank you very much.
Thank you so much for your tips. I will definitely start with the notifications part tomorrow. We got a lot of questions during your talk. So let's start with the first one. How do we balance avoiding interruption with work in small dynamic teams? These need rapid feedback loops and frequent communication.
Okay. If your team is really small, and if you are doing pair programming, your team becomes tiny. Yeah, and because the team becomes tiny, it means that need of communication, the number of not the edges on the communication graph, it just reduces. So try pair programming.
Pair programming, thanks. Where can we find your slides? Everybody wants to.
They are in my laptop. If somebody wants to come and grab my laptop, they are there.
Can somebody come and pick up this laptop?
I would publish them in my personal blog that probably none of you read. I don't know if I will tweet it. I will tweet them now and we'll put them in some place that you can find it.
That would be great. Additionally, there are recordings of all sessions, so you can watch them later or send the links to your colleagues. Another question, how can we efficiently automate ourselves out of the job?
Well, it depends. If you work for yourself, this is the best thing that you can do. Yeah, this is free money. I think it depends on your ethics, right? If you think that you can actually automate your work, why not, right? You finish, people that are using that tool or your business will be very thankful, and we have plenty of jobs around the world, so don't worry about your job. There is a better job working for you.
Okay, I think it's time for our last question. What's the worst distraction for a developer, and is it Slack? Well, why is it Slack?
I don't think it's Slack, to be honest. I think the worst distraction if you have a 2-year-old that is knocking on your door and you work from home. I think that's worse. But I don't think I'm a remote worker. Most of the advice that I give you is when I was not a remote worker. And we use Slack a lot, and I just mute everybody. But they know that if they really need me and they really need to reach me, they know how to get hold of me. So I don't know why we feel offended because somebody don't reply to your joke immediately, right? We should, it doesn't matter. Here, I think the computer is the thing that actually distracts us the most. News, phone. I found my phone more distracting than Slack. So yeah, I don't know if that answers the question, to be honest.
Okay, then thanks again. And